determine the horizontal and vertical asymptotes, bet a lot of you haven't heard that word before, of the rational function, this is f of x, equaling x and divided by x plus 2. That's in a parenthesis, so it's really saying x over x plus 2 as a quantity. Determine the horizontal and vertical asymptotes of the rational function f of x equals x over parentheses x plus 2. So let's take a look at that problem real quickly here. This was, in my opinion, probably one of the harder problems I've given out there. For one thing, many of you have not heard the word asymptote until you get into Algebra 2 and pre-calculus of your high school classes. So this one is kind of out there as a challenge to our, I guess more to our upper level students there, those who've gotten almost through high school algebra. And I was kind of getting it in there, hopefully to get done before you had a bunch of exams. Well, most of those exams happened Friday and Monday, and we didn't get this covered. So, but let's see what we've got anyway, all right? The idea of asymptotes, all right? Horizontal means flat horizontal. That's a y equals equation. We're going to a graph, okay? And the vertical asymptotes are x equals situation, all right? They're an x equals situation, and so that's the first thing I want us to understand. So in looking at, let's go to the x equals, since x comes before, so let's look at the vertical asymptotes, all right? Vertical line, and it's an imaginary line, all right? It's not like it's actually there, but it's a boundary, an imaginary boundary that is separating the graphs, the parts of it, and you'll understand we're going to look at it here in just a minute on the graphing calculator. But a vertical line, and what happens, it basically, remember I said it basically imaginary, it disappears, and the reason it does that is because we get a 0. Now what this is going to be, I'm going to let this look as being y equals x over x plus 2. That is what I want us to see that as, all right? And there are certain things that cannot happen in a denominator. The most important thing, and maybe the biggest thing of it, is, what you won't want to have, is a 0 pop up. And if you get x equals negative 2 in this, in other words, if x plus 2 equals 0, we have a problem. And basically, you just don't want a 0 in any size, shape, or form. So here's what we've got going here. It's going to be x equals negative 2. That is our problem child right there. Because once we put that in there, we have a problem. We can't divide by 0, and that's what it's saying at negative 2 would happen. So in this case, the asymptote is basically what x cannot equal. What x cannot equal. So the vertical line is going to be at x equals 2. You won't see it when we put it on the graphing calculator, but you're going to be able to see there's a gap in the graph right there where that asymptote runs through. Now the other one occurs based on how this function is working. And let's look at it again. Let me rewrite it right down here for you. We've got an x and an x. We want to look at the variable to figure out what the y deal is going to be, what our y for the horizontal, okay? And we look at this x over x, and we notice, forget about the 2, we notice they have the same exponent, which means we want to put the coefficients over each other. So we're going to look at x over x. Now if that had been 2x plus 4, we would have been looking at x over 2x, that kind of thing, all right? But it's just x over x. If, let me point out something else to you, there are a lot of little things going on here. If we had had this as x and this had been x squared, in other words, if this exponent in the denominator were larger than the exponent in the numerator, we'd have y equals 0 for our asymptote. Instead, what we're looking at here is, this is going to give us 1. So here is our y equals 1 for the horizontal. So like I said, that's a little bit tougher, and some of you are like, whoa, where did that all come from? Check out your Algebra 2 rational functions. I understand, I think the state may be removing those from the Algebra 2 curriculum, moving them somewhere else, but yet this year I know it was a big part of those Algebra 2 classes. So those are your horizontal at y equals 1, it's going flat, and the vertical, x equals, did I put 2? I should put a negative 2 there. All right, there we go. We don't want to mess up on that. Negative 2, right there it is. Let me rewrite it again for everybody. All right, x equals negative 2. Now I promised you a quick look on the graph. Let's take a look on the graph. Let's clear everything out here. And let's go to y equals, because that's what we're going to do. We're going to graph this thing. I want you to see what it actually looks like. It's kind of crazy. So we're going to put in an x. We're going to hit divided by, said parenthesis, and it's an x plus 2, x plus 2. Once again, let's enter and let's graph. There it goes, there it goes. Now remember I said something about where the graph, so to speak, looks like it went away. Right there at 2. No, not at 2, -2. We'll get that right. That's a -2 flying right through there. If you look at it, there's like an imaginary line there, and it's really more focus going down, because this little guy is just going to keep squeezing over and over a little bit more until it hits that -2, and it never actually crosses it. It just gets very, 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 very close, very close. So there is your imaginary, and like I said, it's very hard for me on this little mouse to stay, keep that mouse going straight vertical, but you get the idea. Now, that horizontal asymptote at y equals 1 looks like right there is y equals 1, and just slide along there, and it just kind of runs close, close. And that, because the lines are so thick, looks like it's landing there, it's getting real close to the y equals 1 line. That's where the imaginary moment comes, where it basically vanishes to, all right? So there you go. The asymptotes are where the graphs get so close, they just don't cross. They get very, very close, but they never cross. So there you have it, asymptotes, Algebra 2, enjoy.
For more math help, visit TNLearn.org.